Hello students, in the previous lecture we studied the formula of derivative and algebra of derivative. In this lecture we will study type number 1, that is derivatives of addition and subtraction of two or more terms. In exam there is a question, differentiate with respect to x, or sometimes find dy by dx. In the first question, given y is equal to 2 sin x plus 3 log x plus 6 root x, we have to differentiate the equation. Differentiate with respect to x. D by dx of y is equal to d by dx of 2 sin x plus d by dx of 3 log x plus d by dx of 6 root x. There are three terms. In the three terms, there is addition sign. Derivative is separable in addition. Therefore, d by dx of first term, d by dx of second plus d by dx of third term. We know d by dx of k into fx. Taking k outside, take the derivative of fx. Taking k outside, take the derivative of fx. Taking 2 outside, 3 outside, 6 outside. Derivative of sin x is equal to cos x. Derivative of sin x is equal to cos x. Derivative of log x 1 upon x. Derivative of log x 1 upon x. Derivative of root x 1 upon 2 root x. Derivative of root x 1 upon 2 root x. 2 into cos x 2 cos x. 3 into 1 upon x 3 into 1 3 upon x. 2 1s are 2, 2 3s are 6. 3 into 1 3 upon root x is the final answer. Now the second problem is y is equal to 4 tan x plus 3x raised to 4 plus 2 sin inverse of x. They are given y is equal to some function of x. Differentiate with respect to x. Derivative of y with respect to x dy by dx. There are three terms in additive form. Derivative is separable. K into fx, in such type of term we taking k outside. 4 into d by dx of tan x, 3 into d by dx of x raised to 4 plus 2 into d by dx of sin inverse x. We know that derivative of tan x sec square x, derivative of x raised to 4 means x raised to n into x raised to n minus 1, that is 4 into x raised to 4 minus 1. Therefore, derivative of x raised to 4 into x raised to 4 minus 1 plus 2 into derivative of sin inverse of x 1 upon root of 1 minus x square, 4 into sec square x, 4 sec square x. 3 4s are 12 x raised to 4 minus 1 3 plus 2 1s are 2 upon root of 1 minus x square is the final answer. Third problem is y is equal to 3 cos x plus 4 e raised to x plus 2. Now differentiate with respect to x. Derivative of y with respect to x dy by dx. There is a addition between three terms. Derivative is separable. 3 taking outside, d by dx of cos x, 4 outside, d by dx of e raised to x plus d by dx of constant, that is 2. Derivative of cos x minus sin x. Derivative of e raised to x is e raised to x. Derivative of e raised to x is e raised to x. Derivative of constant is equal to 0. How to identify the constant term? The term which does not consist of x or y or variable is called as constant term. Derivative of every constant term is equal to 0. For example, derivative of 2 is 0, derivative of 5 0, derivative of 7 is equal to 0. Therefore, minus 3 sin x plus 4 e raised to x. Minus 3 sin x plus 4 e raised to x is the answer. Now y is equal to root x plus 1 upon root x bracket square. First, in this problem, we have to expand this bracket such as a plus b bracket square. We know that a plus b bracket square is equal to a square plus 2ab plus b square. Therefore, a plus b bracket square means root x square plus 2 into root x into 1 upon root x plus b square means 1 upon root x bracket square. Root x get cancelled. Square root and square get cancelled x. 2 ones are 2. 1 upon root x bracket square means 1 upon x. Now we differentiate with respect to x. Derivative of y dy by dx, derivative of y is a dy by dx. Uh, there is addition between three terms. Derivative is separable. D by dx of x plus d by dx of 2 plus d by dx of 1 upon x. Derivative of x is equal to 1, derivative of x is equal to 1, derivative of constant is equal to 0, derivative of constant is equal to 0. Derivative of 1 upon x minus 1 upon x square, derivative of 1 upon x minus 1 upon x square. This is single variable term, that is 1 upon x, its derivative is minus 1 upon x square. Now 1 plus 0 is 1, plus minus minus 1 upon x square. Now fifth problem is very important problem. Y is equal to a raised to x plus x raised to a plus a raised to a. Differentiate with respect to x, derivative of y with respect to x dy by dx. There is a addition between three terms, a raised to x, x raised to a plus a raised to a. Derivative is separable in this term. Therefore, d by dx of a raised to x plus d by dx of x raised to a plus d by dx of a raised to a. Now there are three types of term. A raised to x, we know that derivative of a raised to x, a raised to x log a. For example, derivative of 2 raised to x, 2 raised to x log 2. Derivative of a raised to x, a raised to x log a. But in case of x raised to a, x raised to a means this term is of type x raised to n, variable raised to constant. X means variable, a means constant. Variable raised to constant means we have to use x raised to n formula. What is x raised to n formula? N into x raised to n minus 1. Therefore, a into x raised to a minus 1, a into x raised to a minus 1. Now, this is the last term which is difficult term actually. We know that a is a constant, a is constant term. Therefore, a raised to a is the new constant, a raised to a is new constant, and derivative of every type of constant term is always 0. For example, 2 is a constant, derivative of 2 0. Therefore, 2 raised to 2 means 4 is again a new constant, derivative of every constant is equal to 0. Therefore, derivative of a raised to a 0. Don't use any of these formulae in this term. Derivative of constant is equal to 0. In another way, we can say that it does not consist of x or y. Therefore, derivative of this term is equal to 0. Therefore, a raised to x log a plus a into x raised to a minus 1 is the final answer. Thank you.